All right. So today we're going to be covering the Eguana Evolve residential battery energy storage system. My name is Jay Zarghami. I am the U.S. Training and Customer Support Manager for Eguana. I've been working with these systems for several years and am happy to provide this session today, as well as any follow-on training or assistance you might need while working with the new product. All right. So today we're going to be covering what's listed on the classroom section, the product introduction. We're looking at features and functions by component. We'll cover design considerations for solar plus storage, both at the product and system level. We'll look at installation requirements, as well as startup and system commissioning. As far as the commissioning training, our format is to do a one-on-one commissioning training with your first system installation. Once the hardware has been installed, review the installation itself, and then the security requirements for connecting to and commissioning the device, and then commissioning it once that's been completed. Some of the acronyms that are used in today's session, you may know, some you may not, but just to do a quick review, BESS, BESS is a battery energy storage system. The PCS is a power control system. BMS is battery management system. EMC is the energy management controller. EMS is energy management system. PV obviously is photovoltaic. ATS, automatic transfer switch, and SLD, single line diagram. PKI is a public key infrastructure. That's just a security certificate that's used on field laptops for commissioning and configuring the controller for the battery system. CT is current transformer, SOC, state of charge. UID is a user identifier. It's sort of like a MAC address for the control, the energy management controller. ECI is Eguana Communications Interface. It's not used for the installation per se, but may be referenced for second level troubleshooting. ARC is auto recovery mode. We'll cover that, as well as the metering functions within the controller, or the PDU, power distribution unit. Product introduction, we'll look at the Evolve system components, system architecture as far as AC coupling solar plus storage overall. We'll look at ATS and EMC functions. We'll look at the PCS architecture as far as the system is concerned, what the layout looks like, as well as battery architecture itself within the DC cabinet. We'll look at LFP battery highlights. That's a lithium iron phosphate chemistry. We'll also look at some battery system protection functions. This is in big letters because I can't stress this enough. All of the resources that I'm using in today's webinar can be found on our website, on our product page for the Evolve, the residential battery energy storage system that we're going to be covering today. The three major resources or reference documents on there are the Evolve Hub installation manual. That's for the EMS. That's the Evolve Hub. And then there's the Evolve LFP or ESS installation and startup manual. ESS is just the product designation for the energy storage system that was originally provided with LG Chem nickel manganese cobalt chemistry, and our newer product has a Pylon Tech lithium iron phosphate chemistry. We'll be covering mostly the LFP product today, but we'll be using those two designations sort of interchangeably during some of the presentation slides. And then also the third reference document is the Evolve Wiring and Commissioning Quick Guide. This is really one of the best resources we have for a day-to-day sort of refresher and guideline for the installation and commissioning process. Once you've gone through the two different manuals, one for the ESS as a whole and one for the energy management system, the Evolve Hub, that wiring and commissioning quick guide will help you on a day-to-day basis in doing these installations. Again, they can be found on the website, on our product webpage listed here. All right, so overall, the system has 4 major components. One is the monitoring, the cloud-based monitoring for remote control, as well as just visibility behind the meter of what the battery is doing, what the home loads are doing, and what the PV is doing. Generation, charge, discharge, and loads, whether you're importing from the grid at net zero or exporting to the grid. This consists of the consumer monitor itself, which is shown in this graphic on the top left. There's also the installer user interface, as well as fleet aggregator tools, where you as an installer will be able to do account administration and remote configurability. The EMS shown in this second graph here is the energy management system enclosure. It performs the functions of energy management and cloud reporting, has PV and load curtailment controls. There's BESS control via Modbus. It also takes care of the system fault handling and reporting, as well as has the automatic transfer switch. The battery energy storage system itself consists of 2 cabinet types, or 2 components. One is the PCS, the power control system, houses the inverter itself. It's a bidirectional inverter, as well as the other power electronics that serve as a battery gateway or a bridge to the AC grid and the AC loads. PCS ensures a safe operation of the battery and inverter, and it's rated at 5 kVA or 5 kW. The DC cabinets house the battery modules themselves, and each battery module itself has a BMS that's integrated to it. The BMS ensures a safer operation of the battery, as well as the DC disconnect that's in this cabinet as well. The sizing on the battery, or the capacity of that battery, will range anywhere from 14 to 42 kilowatt hours for the LFP product, and from 13 to 39 kilowatt hours for the NMC product. I'll be focusing mostly on the LFP product today. Here is a quick sort of like data rundown on the PylonTech lithium iron phosphate battery module. The data sheet is shown here on the right. I won't read through these, but just wanted to kind of highlight a few different things as far as the environmentally conscious nature of the chemistry itself. Has a higher percentage of recyclable materials in it, and the temperature range, where it is effective from -10 degrees C to about 50 degrees C, as well as the warranty, 10-year warranty, or 6,000 cycle life. Okay, real basic introduction to AC coupling, solar, and storage. AC coupled just means that the battery itself is functionally connected at the AC level. The PV, the loads, and the battery itself are all parallel connected to the home load center. It's ideal for the retrofit market for people who've already got PV, and need to stress that there is no PV panel or PV module DC input to the battery itself. Looking at the design functional block layout of the Evolve hub and Evolve battery energy storage system, the energy flow is managed through the EMS panel, or the Evolve hub, shown here. And that's done by taking CT measurements at 3 points. One at the mains, or at the point of common coupling, shown by this red arrow, where we measure import and export to and from the grid. PV is also measured so that we have an active indication of what the production is. And when compared to the import export from the grid, we know what the loads are. We know if we have an excess of generation or an excess of loads, and we can tell the battery to charge or discharge in order to maintain net zero at the grid. It's a pretty simple thing that all battery systems do, but just wanted to lay that out for you in its sort of basic format there. The energy algorithm for solar self-consumption is just as I described. The battery is charged whenever solar is greater than the loads, and the battery is discharged whenever solar is less than the loads. And the excess PV is exported to the grid. And when the grid goes down, the battery will then go from being a current source to being a voltage source. The PV will synchronize to the battery as its new voltage source when the grid goes down, and the loads that are all on the backup loads panel, dedicated backup loads panel, will be served once the battery comes online, which is about a 4-second delay from a grid outage. Quick look at the conduit plan. This is another diagram taken from one of our installation manuals. The battery and the Evolve hub are shown here with the required, per the NEC, required disconnects. The PV, unless it's a micro inverter based system, will require a visible lockable blade type disconnect in order to disconnect it from any loads and the grid itself. And then the two disconnects that are shown here between the battery and the Evolve hub are from the updated, well, as of 2017 updated NEC that requires all non-grounded conductors to and from the battery to have disconnects. These disconnects are not included with the product, but just shown here as a reference to your design staff. I won't get into too much detail here, but the battery architecture is shown on this slide. Both the DC conductor cabling as well as the communications cabling for the LFP battery modules. The connections are laid out in detail and specific for the cables provided with each system and are shown a little bit more clearly in the install manual. So it is very important to pay attention to the communications cabling, especially some of these input and output ports are just, it's directional in terms of the communications layout. So I won't go into too much detail there, but please be aware that those are laid out in the install manual and important to follow closely. So the PCS has some built-in battery protection functions. There's an auto recovery feature where the batteries will go into a hibernation mode if they drop below a critical minimum SOC. This auto recovery feature is the controls that takes the battery out of hibernation as long as there is a grid voltage to recover those batteries. There's no need for any external battery charging equipment after the batteries have shut down with the low SOC threshold being crossed. Once that has been detected with an available grid voltage, the batteries will self-recover. There's also a battery maintenance routine, as most batteries have. If any battery module SOC versus the rack SOC is greater than a 3% delta or difference, the PCS will warn the EMC to prioritize this automated SOC balancing routine following the end of a prior to use case cycle or charge or discharging command. There's also a PCS pre-charge circuit that's sort of a protection layer. It prevents in the inverter. It prevents high inrush currents to the fault capacitors when the battery power is applied. And when shut off, it reduces standby losses in sleep mode. As an FYI there. So as far as system design considerations, we're going to be looking at the PV to battery system ratios, breaker sizing, and in backup power, looking at battery capacity sizing based on nominal load. We'll look at PCS output power limitations. Both inrush and transient performance will be covered. We'll look at typical home load profiles examples, as well as some notable home load cases, which will help for backup load planning. And we'll also be looking at what type of equipment you'd need to measure total black start load profile and a single line diagram review of AC coupled solar plus energy storage system with backup. Okay, real quick here, I'm going to take a quick pause just to see no sound issues. Okay, so we've just got questions being logged in the chat window. That's great. Thank you. Again, as a reminder, please put all your questions in the chat window and we'll do a Q&A session at the end. Getting back to the slides here, the sizing, looking at the PV inverter to battery inverter ratios. As a general rule, it's a 1-to-1. That 1-to-1 ratio is because the battery inverter, bidirectional inverter, is a 5 kW inverter and can only charge at 5 kW, but will discharge with some surge capabilities. The sizing that's important to pay attention to on the backup loads panel is such that we don't want to provide more than 5 kW of excess generation after these loads have been served to the battery, or else it will trip offline. So that means that a safe bet will be to size that solar on that backup loads panel the same to 5 kW limit as the battery inverter itself. This allows the battery to absorb peak PV current until the battery is full. That's if there are no off-grid loads. The battery charge is limited again to 5 kW, that's 20.8 amps. And the battery discharge has limited surge capability up to a total of 8.5 kW for a short duration. Following slides go into a little bit more detail with that. So as you can imagine, it can be the PV can be oversized with caution, probably to about 6 kW based on, so that's nameplate rating. And that's based on array orientation, time of day, and some level of baseline loads. So if you've got a nameplate rating of under 6 kW, your chances of having more than 5 kW excess generation are pretty well regulated, just by that sort of like field experience, trial and error. And for systems that have quite a bit more than that 5 kW or even 6 kW of PV, it'll be required to split that up if you don't have a way to curtail the PV when you go to off-grid mode. If you work with SolarEdge inverters, we can use up to a 7.6 kW SolarEdge inverter here because the SolarEdge has a method of controlling its output through a PRI, or power reduction interface. As far as any of the other solar inverter manufacturers, I don't know of any other way that, without using a relay, of course, that any of those other manufacturers will allow us to curtail them or to derate their inverters when we go to a backup mode. So for systems that are significantly larger than 6 kW, the PV needs to be split up into a portion that's landed on the backup loads panel, and then the rest is landed directly to the main service panel. That total PV system size will only be limited by the interconnection regulation. So from the utility and that bus rating at the panel. Obviously you can do a line side tap, but we won't get into that here. So as far as backup power, the Evolve system is rated for emergency backup power only. It's not intended for off-grid only systems. It is black start capable for both loads and solar PV. That means it is a voltage source when necessary. It's a current source, again, when synced to the grid voltage. And when the grid source is down during a grid outage, the inverter becomes a voltage source, and it is black start capable for both loads and PV. A lot of people ask about whole home backup, and without getting into too much detail here, obviously whole home backup is not possible without some sort of load management. So you don't have some type of smart load control and a special interconnection and switching topology, then whole home backup really isn't possible. And in my opinion, you're not backing up the whole home if you've got to add extra components in order to shed those loads. We won't get into too much of that here, but just be aware that loads are required to be relocated into a dedicated backup loads panel with PV for this system. Okay, as an exercise, what capacity would you reserve for emergency backup power? Well, it depends. How long are your outages on average and what size are your loads? And then looking at the PCS limits of the Evolve when in backup mode, that bidirectional inverter is a 5 kVA, so its continuous power rating is shown here on the left, about 2.5 kVA per phase, and it's got a surge rating of a maximum of 170% of nameplate, which is 8.5 kVA for about 5 seconds. It'll surge up to 120% of nameplate rating, which is about 6 kW for up to 30 minutes. It will also withstand about an 8 amp, 100 microsecond transient peak. And in coming slides, we'll look at what types of loads have a transient peak effect on the voltage waveform and what that can do when it's exceeded. So a quick overview of typical home loads is shown here and the types of loads that they are as far as continuous surge rating requirements or transient peak type characteristics. They're all shown here, or some examples are shown here. A toaster, for example, or a simple heating element is a continuous load, purely continuous load. It has no surge characteristics. And there are most items will fit kind of in between the two. It's got a limited or at least a baseline continuous load requirement, and then may have some surge characteristics, like, for example, when a refrigerator's compressor cycles on and off, you'll have a little bit of inrush, or actually quite a bit of inrush compared to its base level load requirement or current requirement. And then you've got a number of home electronics, typical home electronics, which will have characteristics both of continuous loads and then transient spikes as well. Like a lot of consumer electronics have switch mode power supplies that do just that. Gas ignited light bulbs, for example, have a transient peak characteristic on the voltage waveform and are probably best to be avoided in large numbers when looking at the backup loads planning. Like CFLs or large banks of fluorescent lights can wreak havoc on these battery inverters because of the cumulative transient spike effect on the voltage waveform. So again, backup load planning is really important. You've got to measure it to be sure what the characteristics are when it goes through its cycles of inrush to base level load. You can find out what the anticipated or approximate requirements are if you look at the manufacturer's nameplate for that rating, but unless you measure it, you really can't be sure. This is an example of a refrigerator that the manufacturer stated had a 3 times continuous surge peak, but it was measured at right about 10 times that base level load. So while I don't expect people to have a field oscope or a data scope to measure that, an inrush detection fluke meter or any other kind of ammeter with inrush detection on it will show you that. Transient spikes, however, a little bit harder to measure. An ammeter with or without inrush detection will still not be able to read those transient spikes. So just be aware when you've got a lot of those types of loads that you could end up with servicing problems when that battery trips offline in an off-grid mode. So try to avoid those types of loads if at all possible, or try to mitigate them. If you've got a lot of home electronics, for example, a home office with, say, a laser printer and a few other devices with those switch mode power supplies on them, you can mitigate the transient spike effect by putting on a UPS, just a standard home office uninterruptible power system will filter out those transient spikes from the Evolve battery, protecting it from tripping offline in backup mode. And it'll also provide the added benefit of protecting those devices from that 4-second outage when the grid goes down. That would be for these. So again, to measure those types of loads or those voltage characteristics, it's easy enough to measure the continuous current for loads with a standard ammeter. For motor loads or any type of inrush detection, you'd need to have that inrush feature built in on an ammeter, and those are pretty common nowadays and not too much more expensive than a standard ammeter. As far as measuring transient spikes, it's really not necessary, but this graphic just shows the type of equipment that would be able to measure that. So in quick summary, the backup power capabilities of the Evolve, it's rated for 5 kW continuous. Black start of PV and all loads must take into account all limits, continuous, surge, and peak transient. The surge rating is 170% of nameplate for 5 seconds. It's about 35 amps. And it'll do 120% of nameplate for about 30 minutes. And that's about 25 amps. The home load profile may constrain the backup power limits due to a high quantity of nonlinear loads. And of course, you want to balance your loads between the phases, L1 and L2, on that backup loads panel. For example, if you've got a refrigerator and a microwave, if it's possible to put them on opposite phases, then there's going to be a lot less chance that both of them are cycling at the same time on one phase and exceed the surge rating. And again, it's really important to measure what those characteristics are. Okay, now looking at installation of the system, quick review of the single line diagram. And again, all of these graphics are taken from our installation manuals that can be found on our product webpage. This is from the Evolve Hub installation manual. This is a sample single line diagram showing the PV going into the dedicated backup load subpanel and how it's routed through the Evolve Hub, as is the Evolve LFP battery system itself through the Evolve Hub, and what that routing looks like when the grid is up and which relays are activated when the grid goes down in order to connect the battery directly to the backup power subpanel, backup loads panel. Okay, some basic considerations for installation of the system are environmental, structural, and some wiring considerations. As far as the environmental part is concerned, obviously, again, the battery is rated for -10 degrees to +50 degrees C. If you've got an environment where you're going to be exceeding these, especially down on the lower end of that scale, it's highly advisable to install it indoors. Although it is outdoor rated, it's a NEMA 3R enclosure. It's also indoor approved, so you've got quite a bit of flexibility as to where you can install the system. Try to avoid installing it in direct sunlight. So north-facing exterior walls are usually a best bet, or maybe inside a garage. The battery cabinet is convection cooling only, so keep that in mind. But the inverter cabinet itself does have active cooling. There are 2 fans in the inverter cabinet. As far as structural considerations, since this is a wall-mounted system only, that wall or that structure must be load supporting. As far as some of the wiring considerations when installing these systems, in addition to the AC conductors, you've got CTs that are wired between the control or the EMS and the PCS or the battery cabinet, as well as the PV CT and the mains CT at the point of common coupling or the service panel. Those CT wires that come with the CTs are rated at 600 volts, are twisted pair, so you can put them in the same conduit as conductors, but is probably a best practice to put them in dedicated conduits. The Evolve Hub backup control relay, or the backup control itself, relies on an AK1 relay connection to the PCS. We'll look at some of that in the coming slides. The EMC to PCS communication is also another control wire that you've got to take into consideration. The wires that come provided with the system for that purpose are also rated at 600 volts and can be included in the conductor conduit. But if one of those best practices type of sticklers, it's probably better to put it in its own dedicated conduit. As a force of habit, some people like to do that. So anyways, as far as the battery module connections, please pay close attention to those connections in the DC cabinet, as they are pretty specific. Okay, looking at the conduit plan, here is another graphic taken from our installation manuals. It is the conduit plan for the overall system, showing all of the recommended conductors and circuit protection for those interconnections. The CT pigtails that come with the system are standard 8-foot long, but they can be extended with proper wiring up to a maximum of 500 feet. Quick note on these little symbols here. The red ones are noting to not drill into either of the battery cabinets. The intercabinet knockouts or pass-through ports are built in, and the PCS cabinet has knockouts on the bottom that are more than enough for all of the required interconnections. Oh, and then the Evolve Hub itself, it has a green drill symbol here, and the details are shown in the Evolve Hub manual, but that note just basically states that drilling is mostly just permitted or suggested on the bottom side of that enclosure. There are RF antennas, adhesive antennas that cover the top part of the enclosure, and some of the clearances and spacing inside the Evolve Hub itself don't allow for drilling on the side. So just drill into the bottom of the Evolve Hub enclosure and not at all into either of the inverter cabinets. Okay, taking a quick look at one of the other resources that I mentioned at the beginning of the session, the Evolve Wiring and Commissioning Quick Guide. Shown in its entirety here on the right side, there are some really good details shown, the arrows pointing to an example here or here, like for example, where in the Evolve PCS cabinet, the circle shown on the quick guide shows where this further detail is on the AC filter board, where the battery CTs are landed. And the arrows shown on the CTs show which direction the arrows point for those CTs. Again, the details for the AK1 wiring, which would be on the first page of the quick guide, are shown here, where that AK1 connector is and what type of conductor gets connected to that connector and then back over to the Evolve Hub. The second page of that quick guide shows the commissioning steps required, and those are reviewed in more detail during the commissioning phase of the training. So once it's been installed, that's it. You've got it all wired and ready to turn on. At this point, you would power up the Evolve battery system itself. Well, step one would be to turn on the Evolve hub breaker at the main panel. That's the 40 amp 2-pole breaker at the service panel, which applies power to the whole system. Next, you would turn on and by turning on that power, you apply power to the backup loads panel as well as the Evolve hub itself. And it can run like that without the battery as long as that AK1 wire has been made. The next step would be to turn on all the power switches on the battery modules themselves, shown here with that blue arrow where the power switches are. And then next you would press the SW button on the master battery module only. That denotes that module as the master and assigns addresses to all of the other battery modules in the rack. Next, you would turn on the battery disconnect, the DC disconnect, which powers on the battery inverter. After that, you turn on the battery AC disconnect, one or more, at least the grid side one, will apply grid voltage to the Evolve, and the 5-minute grid connect timer starts. Once it's been powered up, then you're on to the commissioning steps of the controller. We're going to cover prerequisites here, some of the pre-commissioning steps, and then a brief look at the commissioning itself. The prerequisites for commissioning are a device with a web browser and a USB port on it. That could be, that's in most cases, a laptop. It could be a tablet for those of you who have the ability to connect a USB wire through that tablet. Chrome is the recommended browser and easy enough for most people to work with, but it will also work with Firefox. Do not use Internet Explorer. There are just constantly problems with Internet Explorer. Obviously, you're going to need an internet connection for a cloud pathway for monitoring, as well as the remote firmware updates and any remote configuration changes you might need to make in the future. There's a PKI certificate, that's a public key infrastructure or security certificate for your field commissioning device, a laptop or tablet, whatever it may be. And that PKI certificate needs to be loaded onto the device, onto your laptop before commissioning can be completed. Okay, a couple of pre-commissioning steps.
Hello.
Please mute your microphones. I can hear somebody saying hello there, but thank you for muting your microphone. Okay, again, pre-commissioning steps. First of all, there's some administrative steps that are one-time only, and that's to log into the installer account and obtain that PKI certificate for your field laptop. Once that's done and you're ready to turn on and commission the controller, you'd power on the system. The Evolve hub would be powered on, and that applies power to the energy management controller itself. You don't need a security certificate to get it connected to the customer's Wi-Fi. You can also wire it, hardwire it with Ethernet, Cat5, Cat6 cable to the controller. So you can go either wired or Wi-Fi. There's also cellular capability on these controllers, but the SIM cards that are provided are not activated. So activating them would be another step that we could discuss at another time. Okay, so as far as getting it connected to the customer Wi-Fi, if you're using Wi-Fi, you would just put in the SSID and password. The EMC would then report to the cloud server, and that server issues a list of approved PKI certificates to that controller, and you're then able to connect to the commissioning and configuring part of the local gateway app. Once you're connected to it, you would, on the cloud application, you would record the UID and the customer's information, onboarding that device to your installer group. Once that's been done, then it's a process of stepping through the first few pages on that gateway app to input the energy algorithm, whether it's self-supply or time of use, for example, some of the other relay settings, and then on to configuring the CTs and doing a quick calibration step at the end. Again, follow the quick guide, the wiring and commissioning quick guide. That has all the steps required for completing the installation. And then once that's done, that's it. So I'm going to go back here to the first page and have my email on here as another reference for you folks. And then again, you can always go to the product web page to download any of the resource materials shown during the slide. All right, so I see that we've got a few questions on the chat window. I'm going to go through those and one by one. And if at the end of those questions, if there's some, a verbal requirement, if you need to, get clarification on that answer or whatever, I'm going to ask Courtney to unmute the group, and I'll just remind you again to mute your microphone from your side so that there's a minimum of background noise during the Q&A session. So first question from Ricardo Ampudia is, what's the difference of your systems with other providers, among others, Tesla, Humless, Eaton, Lib Energy, etc.? What's the difference? Well, there are quite a few differences. You can compare the data sheets side by side. That's probably one of the easiest things. One of the major differences that it falls into the AC coupled category versus DC coupled. That's one of the major differences with some of the systems out there. Tesla used to be a DC coupled only, then they had DC and AC, and now they only have AC coupled systems. Eguana saw the flexibility and the applicability as far as the being able to go from installing a new system with this type of design, the AC coupling, as well as being able to use it for a retrofit to an existing PV. So AC coupling offers you that benefit, as well as some of the redundant, it eliminates a single point of failure that exists in a DC coupled system. So there are some ups and downs to both, but I think probably a better way to compare the differences would be to just kind of put the data sheets side by side, whether it's the power rating or the interconnection topology or design. Those are some of the major differences. When it comes to basic battery warranty, most batteries fall under the same 10-year warranty guidelines. So those are pretty similar. When it comes to time in market and the battery platform itself, the Eguana battery inverter in one form or another has existed and evolved, pardon the pun, I guess, but over the past 20 years or so. Eguana's been around for quite a long time as a white label power electronics or inverter manufacturer in other larger integrator systems. And in the past 5 years or so, Eguana has been a system integrator themselves. When it comes to some of the flexibility as far as adding capacity, the Eguana has an advantage from Tesla or some of the other ones. When you want to have a larger capacity system, you can just bolt on extra battery cabinets to the Evolve and increase that capacity without having to add another inverter. So those are some of the differences. Probably one of the major differences is the control platform. The user interface for the consumer as well as for the installer is probably the most advanced or one of the most advanced out there. Doesn't quite have the shine that, like, you know, we don't use a smartphone app for the consumer user interface. For example, the design of that software allows you to go from laptop, desktop computer to a tablet or to a smartphone, and the block layout of that user interface would display similarly as shown here on this slide, where you've got this is the consumer user interface. Its layout, these blocks, that block format realigns and repositions itself on the window to look the same whether you're on a smartphone or on a larger format viewing device. Any specific comparisons that you'd like to make that I didn't go over, feel free to email me, reach out after this, and let me know, and I'll be glad to go over those with you. All right, so next question, Ricardo, I hope that answers your question. If not, we can follow up after this for any further details. Moving on to the next question here, Josh Brown. Can a solar plus storage system also charge from the grid as well? Yes, it can. It can charge from the grid, and in fact, our low-level battery maintenance features that are built in, for protection of battery health, will actually pull a low-level charge from the grid if there's no PV for extended periods of time, or else shut it down. Also, it charges from the grid when the auto recovery feature kicks in. But as far as high power charging, it can charge from the grid, but the controller is not set up to allow that, just to help your customers maintain the compliance requirements for the ITC, as well as a lot of utilities won't allow high power charging from stationary battery systems. For those AHJs or those utilities that will allow that, please let us know. There's a way that we can allow the charging from the grid. Okay, from William Turner. Josh, I hope that answers your question. If not, again, you can follow up with me after this session. Either shoot me an email or give me a call. All right, William Turner, on our basic schematic, where does a standby backup generator fit in? That's a great question. That's why it's not shown on our basic schematic, is because fuel generator is, because they come in all different shapes and sizes, and communications methodology, controlling a generator is really hard to do on a standardized control platform. And because that fuel generator does need to be controlled, whether you've got a dump type load, if the battery is full, or any other reason that you'd have to control that generator, different types of generators have different types of control. And so it's not shown because we generally consider the battery system to not be compatible with a fuel generator. So as far as charging the batteries from a generator, it's not designed to do that. And so as far as on the schematic where it would fit in, you would have to have an ATS between the hub interconnection to the service panel and that generator itself. The battery would have to be isolated from the generator if you wanted to serve loads from a fuel type generator. Okay, and again, William, thanks for your question. If you've got any further details that you'd like to discuss, you can feel free to email or call me, and I'll be glad to go through that with you. All right, next question from Dean. As per your wiring picture, you show the solar being tied into the sub panel with power outage. Will the solar inverter remain on, or is it shutting down in backup? Great question, and that's why the solar inverter is integrated with the backup loads panel, because the battery goes from being synchronized to the grid voltage to serving those backup loads as a voltage source when the grid is down. That same voltage source becomes your new synchronizing voltage for the solar inverter. So once during an outage, so say the sequence of events is when the grid goes down, that connection is lost and there's a 4-second delay before the battery comes online as a voltage source. Those backup loads are then served after that 4-second outage. All the lights and everything come back on. That solar inverter that's connected to that backup loads panel will see that new voltage source as its synchronizing voltage. And after the standard 5-minute synchronizing timer goes, that solar inverter will then start serving those backup loads in an off-grid mode, and any excess PV generation will go into charging the battery in the that microgrid type of setup. That'll maintain in off-grid mode as long as there's available sunlight and you know, the batteries you know, being charged on a daily basis. Obviously, it's a you know, balancing equation, you know, between the loads and the generation. You want to be able to generate enough power to serve some of the loads, but also to charge the battery so that those loads can be served by stored energy throughout the night till the next day. Okay. And then, so that hopefully that answers your question, Dean. And then the next question, I'm going to go on to the next one, is from John. Is Eguana planning to develop and sell an off-grid version of our products? Simply put, no. We specialize in grid-tied battery energy storage systems. They will work in a backup or islanded mode, but and they would essentially work for an off-grid only system, but some of the features that are built into it, like auto recovery, are not going to be available because there's no grid voltage. It's meant to do solar self-consumption and time of use to eliminate or at least minimize import from the grid and help to maximize a grid customer's savings on their utility bill through time of use rate arbitrage. And then second part of your question, do Eguana products provide any capability to manage AC power factor changes within the residential building? While grid tied, there is no active power factor changes that are done. It will automatically provide some VARs, and the power factor will change based on what is on the grid or what's on the service panel. So it does have power factor control from 0.8 lagging to 0.8 leading. It does comply with all the advanced inverter controls and reactions required in California Rule 21A, all the way up through the phase 2 and phase 3 communications controls. So it does have quite a bit of capability built into it. Hopefully that answers your question, John. If not, if you've got any clarifying points you'd like me to make, please feel free to reach out either on email or call me. All right, next question from David. If installing in a garage, for example, is there a distance limit for the wiring from the Evolve unit to the main electrical panel? No. There's no limit. Technically, you can extend any one of the conductors, either the AC conductors or the CT wires required for that connection. Again, as mentioned in one of the slides, if you're going to extend the CT wires, they can be, I guess this is a limit, but not if you're going to be inside a garage. The limit on extending CT wires is 500 feet. So I think that'll probably do for most residential installations. hopefully that answers your question. If you've got any specific questions that maybe I wasn't clear on, again, feel free to email me or give me a call. Please add support for the Apple Safari browser. That's a great request, question, whatever that is. I use a MacBook Pro for many years. It does have support. It does work, but updating, it's kind of hard to keep up with all the different browsers on our software development side. So we try to standardize and limit our development efforts and expenditures to a few browsers because they are updated, whether it goes from the bit, design, what go up to a 32-bit, whatever, all of that, all the different changes that can happen from the OS itself to the browser, whether it's security settings or just functionality. It's easier to keep up with just a couple. So I use Chrome on my MacBook Pro and have not had problems with that. So I would suggest doing that if you use an Apple. All right. Ricardo, thank you. All right. Indra, next question. Does Eguana battery qualify for S-chip rebate in California? Is it listed in CEC? Yes, it does, and yes, it is. With a qualifier there, the S-chip requirements, the paperwork, and the listing on the CEC is done for the NMC product, and we're waiting for. That's weird. Anyways, waiting for inclusion for the LFP product now. That testing has been completed, and it just takes some time to get it listed with CEC. But yes, it is on the approved inverter list. Rachel Reif. Hi, Rachel. Rachel's question, is the backend battery portal to program, reprogram, give client access, etc. through Eguana? Yes. If we use Enphase, is there a way to show battery info on their monitoring platform? How many cycles are estimated per battery? Great question, Rachel. And you'll have to talk to Enphase about showing anything on their monitoring platform. I've worked in the product development engineering capacity with Enphase for probably, attempted to for probably close to 7 or 8 years now. I was the first hire for eGear, the control platform, the EMC for this product, and Enphase is notorious for not letting anybody have access into or either putting data into the Envoy or pulling data from it, whether you want to do inverter monitoring and control or any type of integration work like that. Enphase is notorious for being exclusive. But on the other hand, our monitoring platform, which is shown on one of the earlier slides here. So this is the consumer user interface, and it has full behind the meter visibility for that customer that shows PV monitoring as well as battery and loads monitoring. So I would suggest if you'd like to have a one-stop shop or a single portal for all of your customers, the monitoring user interface that we provide shows that and also has a direct link to Enlighten or any other solar manufacturer's monitoring platform as well. So if your customers were to log into your monitoring system that we provide you, which you can actually customize with your own logos and all of that, they'll be able to see everything that's happening behind the meter at their home, as well as through that portal be able to go into the solar inverter monitoring platform. So great question as far as monitoring is concerned. As far as how many cycles are estimated per battery, it's warranted for 6,000 full cycles and has an expected serviceability that I think goes for another couple thousand after that. Ricardo, it did, thanks. All right, well, I'm glad. Thank you, Ricardo, for your question. Dale's question, is the transfer delay really 4 seconds and not 4 milliseconds? Yes, it is really 4 seconds. It's it's connected differently if you're used to installing like a line side cap for Tesla systems, for example. The synchronization is different, and the inverter design is different, such that a disconnect from the hold on just a second here. Have this mark up. I'm drawing on the screen and didn't even know it. Anyways, yeah, getting back to the question here, as far as the transfer delay, yes, it is 4 seconds. So it's 4 seconds so that in case the grid was to go down and then back up within a second or so, within a short period of time, that the inverter doesn't conflict with that. And so it does have an isolation delay of 4 seconds. Okay. Let's see here. I'm gonna try and get rid of this stuff here. This extra little stuff. All right. Anyways, next question. And Dale, thank you for your question. If you've got any other clarifying comments to make, please let me know either here in the chat window, or you can, again, reach out to me by email or give me a call. Russell's question, can the Evolve be remotely dispatched, for example, to enable participation in a demand response program? Yes. Actually, the controller, the energy management controller in the Evolve Hub was one of the first controllers to be OpenADR and CSIP compliant. So whether it's a demand response type dispatch command that's issued or that you'd like to have issued, it will respond to those signals. Josh, glad your question was answered. Thank you. Dean's question says, with new code changes coming to Canada, any over 1 kW needs to be not attached to the dwelling unit. Were you aware of this, and what are you doing to address this? I'm not aware of that. And I'm guessing any battery over 1 kilowatt needs to be not attached to the dwelling unit. Not sure what you mean by not attached, if it's that electrically or physically. No, I was not aware of this. Being that the battery may have to be installed outside. Oh, tonight's supposed to be minus 37 degrees C. Well, I feel very sorry for you. That is a ungodly cold temperature. And any battery system, any lithium ion battery system is going to have a problem at that temperature. That's just inherent to the chemistry, the physics of battery energy storage and how electrons work in those storage medium. So are we doing anything to address the temperature issue at the low end? We're not planning on putting any type of temperature regulation on the residential product to keep it warm in sub-zero freezing conditions like that, no. As far as not attached to the dwelling unit, if you could please email me, Dean. Again, my email is listed at the beginning of the presentation. There it is there. Excuse me. Please shoot me an email with a reference to what you're talking about. And since Eguana is based in Canada, I'm sure that the engineering, the R&D team is able to address that and probably more familiar with that than I am. I'm based out of the US and really have only worked in the US. Thank you for your question, Dean, and thanks for bringing that to my attention. I had no idea. All right, Russell. Russell's question, are there plans to support larger power requirements in backup mode, perhaps with a larger inverter or the ability to stack 2 5 kW Evolves to one backup load panel? As a matter of fact, yes, we're already in development for an Evolve product that is exactly that. It is 2 of those 5 kW inverters in one system with using the same components and same battery layout. So you'll have the larger capacity as well as the larger power component probably by end of year. It's been in production for several months now, and I think they're planning, the R&D team is planning on going to UL certification for the 10 kW product probably by summertime, before summer, I think. So by end of year, we're hoping to have a production unit available at the 10 kW rating. All right. Rachel and Russell, thanks for your question. If you've got any more specific or follow-on questions regarding the 10 kW product, then please do reach out, send me an email. I'll be glad to continue that discussion with you. But as far as stacking 2 separate 5 kW Evolves onto one backup load panel, that cannot be done. I won't go into too much detail, but the hardware design of the battery PCS cabinet does not allow it to do that. We can go through that in detail on another time. We can do that one-on-one, but as of right now, we cannot stack 2 onto one backup loads panel, but we will have a 10 kW system that will be able to give you the same effect. And thank you for your question. Rachel, thank you. Let's see, your question follow-up is, what average reserve do you see most people set to be ready for blackout? If you mean SOC reserve, it really depends. That could be, anything from, 30 or 40% to, 90%. But there's a really neat feature in the consumer user interface that allows for, hold on here. Oh man, losing control. Anyways, so it allows for the customer to anticipate a grid outage. It's called Enable Emergency Power Reserve. We used to call it Storm Watch. And then after a private meeting with Tesla several years ago, Tesla took that name and feature from us and called theirs Storm Watch. So we changed ours. But anyways, any Tesla fans out there, sorry, that's Tesla. But anyways, yes, you can still do that through the consumer user interface. The customer can change the reserve level in anticipation of a grid outage and maximize the battery charge prior to that outage. If they're, for example, if they're using time of use and would like to, have a little bit, more ease of mind when setting that, it does come with a timer. So say, for example, they want to set it for the next couple of days to have that emergency power reserve, they can set it. And when that grid outage occurs, the battery charge will be at maximum. And if if that grid outage never does occur, that time has elapsed that they set, then it'll go back to their original default so that they can continue to reap the benefits, the financial rewards of using time of use, for example, without having to remember to go back and reset it to what it was before. So there's quite a bit of, kind of like usability and sort of protection features that are built into it. Hopefully it answers your question, Rachel. If not, I'd be glad to go over go over that in greater detail one-on-one. So just reach out if you'd like to do that. Let's see, Russell, what kind of reporting is provided? For example, can we report the hourly energy flows to from batteries on a monthly basis? Yes, through the installer user interface, you can do very detailed reporting. It's actually, I believe it's 15-second data that's reported every minute, that's gathered every minute and uploaded to the cloud every 5 minutes. So if you wanted to have detailed reporting on anything from charge, discharge, state of charge, PV production, load requirements, anything like that, anything that's gathered by the controller, measured and reported to the cloud is accessible through your installer user interface, as well as accessible through the consumer user interface through the data download feature. And when you take a look at the installer UI or the consumer UI, you'll see that in the production graph area. So yes, you can download CSV type files for detailed information. Dean, qualifier physically. So I guess that's the separation constraint. No, I wasn't still not aware of that requirement or constraint in Canada. If you would like to follow up afterwards, please feel free to reach out. I'll shoot a quick message to our R&D folks in Calgary and see if they're aware of that, and if so, what they have in mind to accommodate that requirement. Courtney, thanks for putting my email up on the chat window. Dale, Dean, post a web link to that 1 kW or less only in a house rule. Oh, okay. Thank you, Dale. David, what is the solar wattage recommendation when the 10 kW system is released? Again, that'll be scaled based on the battery's charge rating, and it's going to be, I would anticipate that it would scale linearly along with the size of the battery inverter. So if you've got a 10 kW battery system with variable capacity, again, up to 42 kilowatt hours, that paired PV system would probably also follow the same one-to-one guideline with a slight oversizing on the nameplate rating for that system. So you're looking at probably 10 to maybe as much as 12 manageable PV, 10 to 12 maybe kW of PV on that backup loads panel. Unless you've got, for example, SolarEdge PV inverters where we have an interface to derate the PV when in backup mode. So you could then effectively tie maybe as much as 15 plus kW of PV onto that backup loads panel that would work at full rating while grid tied. And then when it goes to off-grid mode, be derated down to the 10 to 12 level. So great question. Let me know if you'd like details on that SolarEdge PRI connection. You can find it on their website too, but if you'd like to discuss that one-on-one, please feel free to reach out, send me an email or something. Thanks for that question, David. Bill, will the 10 kW then be rated at 40 amps? If you mean, as far as the battery inverter itself, it'll follow the kVA rating, the power rating for that inverter. If you're talking about the interconnection device, it will have an option to go up to, I would say twice that, up to 80 amps. So the interconnection device design, the Evolve Hub updated design, is not completed yet. I would anticipate that it would be as much as 80 amps on that. All right, Rachel, glad to answer your previous question. It seems like that's the end of the questions on the chat window here. again, I'd like to thank everyone who attended today's session, and repeat that if anyone's got any follow-up that they'd like me to discuss with them one-on-one, please send me an email. My email address is shown here on the screen, j.zarghami@eguanatech.com. For those of you who've already been in touch with me via email, you've got my my cell phone number is on my signature. So happy to discuss anything with you on your design phases of installing your first system up through commissioning. Obviously, that's going to be a requirement to schedule that first system commissioning with me, and then I'm always available for support after that as well. So thank you again, everyone, for attending today's session, and I will leave it at that. Thanks again, and we'll see you next time.